what we're going to work on bulk of the day today, guys, is practicing our naming here. All right, your quiz tomorrow is going to be on naming compounds. There'll be some ionic, there'll be some molecular, there'll be some ionic that require a Roman numeral. Okay, so you got to know how to do them all. And on the sheet you have there, okay, you've got examples of all of them. All right, this first sheet here is about making the formulas, and then you've got a couple of other sheets where they give you the formulas and you have to practice making the names. I would say, do about 10 from one sheet, then do 10 from the next sheet so that you're practicing kind of evenly. Otherwise, you might spend the whole day just doing formulas and then you haven't practiced the naming part, and then you're not ready for that tomorrow. All right, so I would say do about 10 from each sheet. Just want to quickly review, a couple of examples of each here that are on your sheet, so you can have a look at those. So here, when we're making formulas, the first step, whether it's ionic or molecular, is to decide whether it is ionic or molecular. Okay, so let's say we're looking at 3 here. Number 3, we've got manganese 4 oxide. Manganese is a metal, so this is what kind of compound? It's ionic. All right. When we have an ionic compound, we write the metal and its charge. How do I know the charge on manganese since it has 2? I do that if I'm writing the formula, but this actually tells me the Roman numeral. Okay, the Roman numeral tells me the charge on manganese is 4, not 2, because there's 2 options on that. All right, so I write manganese is 4 plus, and oxygen. Oxygen's always minus 2. Okay, when I'm dealing with an ionic compound, I drop and swap the charges. So I drop the 2 and swap it over to here. I drop the 4 and swap it over to here. I'm left with Mn2O4. Is that where I leave it? Okay, what do I do with the 2 and the 4? Right, I reduced to 1 and 2. So my actual formula is MnO2. All right, so that example there is essentially made you have to do absolutely anything that could possibly happen while naming an ionic compound. All right, another one we might deal with here, like number 5, we've got potassium permanganate. Now, oftentimes when people arrive at one like that, they look all over the periodic table for something called permanganate, and lo and behold, they don't find it, because permanganate is where? Right, it's one of the polyatomic ions. So if you've looked all over the place, on your periodic table, I'll tell you a way to save you time. If it ends in 8, it ain't an element. Okay, nice, right? If it doesn't end in "ide" or "ium," it's not an element. Okay, so if it ends in 8, you got to look in on the table of polyatomic ions. All right, so same as before, we write K. It's a metal. It's +1, and permanganate is MnO4. Okay, it's -1. When I drop and swap those, it's 1 and 1. So I can just write this as KMnO4. Okay, other examples here, if we run into, let's say, a molecular compound like number 15. We've got diphosphorus pentaoxide. Di means how many? 2. All right. I don't have to do any charges or any swapping and dropping for the molecular ones. Pentaoxide is O5, and I'm done. Hey, is that ringing the bell for everybody? All right. If we're doing the other part, where we've got, we're given formulas, and we have to write the names. Yeah, Caroline? It's +1. Ammonium is +1. It's the only one on that chart that's positive. Okay. All right. So for let's say, I don't know, number 5 here. All right. I've got aluminum and bromine. Is that an ionic compound or a molecular compound? It's ionic because aluminum is a metal. All right. So we simply write it aluminum or aluminium. Okay. Bromide. Do I have to put a prefix on that one? No, because it's ionic. Does aluminum need a Roman numeral? Does it have more than one possible charge, or does it just have one possible charge? Okay, it's +3, right? Only has one possible charge. All right, so it doesn't require the Roman numerals. Okay, if we have a molecular compound, like this one here, we write carbon. Okay, and then there's 2 oxygens, so I need di on that one, carbon dioxide. And let's see if we can find one that needs a Roman numeral here. Okay, how about number 28? 28 will need a Roman numeral. I've got lead and sulfur together. Lead has two possible charges, 2 and 4. All right, I need to figure out which one, so I put the right Roman numeral in the name. All right, so I'll start out like this, lead and sulfide. But now I need to figure out what the charge on lead is. Sulfur is always -2. So what's the charge on lead in this compound? +2. So this is lead 2 sulfide. All right, so now we've kind of gone over one of every kind that you could run into. Okay, so now I want you guys, okay, practicing that stuff from those sheets. Like I say, do 5 or 10 from one sheet, move on to another sheet so you're trying different things. You're not just doing all formulas or all naming. Okay, the keys are on my website, so if you want to check them on your phone as you go, okay, or if you really want, you can come up here, okay, tap the smartboard and check the one you want to see. All right, probably easier though if you just call it up on your phone. You don't have to, walk all that way up here. Yeah. Okay, so they're on my website and they're naming key 1, naming key 2, naming key 3. Okay, in the chemistry folder. Okay, so guys, just a quick reminder here. We'll just look at another example here. Number 7. Okay, we've got not only a multivalent metal, but we also have a polyatomic ion with hydroxide here on number 7. Okay, so we set it up like any other ionic compound. Copper, and they tell us it's the 2+ copper, okay, is with hydroxide, OH. Okay, that's -1. So when I drop and swap, the 1 comes to the copper, and we don't write 1s. But then I need a 2 out here. But I have to make sure that 2 applies to the whole thing. Okay, so remember, if you've got to put a number down beside a polyatomic ion, you have to surround that ion with brackets. Okay, we talked about that where we could have ended up with 42 oxygens in that one compound that we were dealing with the other day. Okay, and we don't want that to happen. So if you have to, in a swap and drop, put a number other than 1 beside a polyatomic ion, surround it with brackets, put the number outside the brackets. Okay, guys, so number 29 on that first sheet that I gave you, there's a mistake on the key. Okay, if you're looking at the key on number 29, there's a mistake. On the key, it says that aluminum nitride should be Al2N3 or something like that. That's not right. Okay, aluminum nitride, okay, is an ionic compound. Aluminum is +3, nitrogen is -3. What do those two things do? They cancel. All right, that means your formula is Aln. So it's a mistake on the key. Right, just be aware of it. For that first page I gave you, number 29 on the key is wrong. It should be Aln. All right. Are there any ones that you want to go over right now? Well, now that you've had a chance to do a few. All right. No, I'm not going over the quiz. No. Okay. Any other ones not on the quiz? Okay. Okay, which number from which worksheet? Yeah, I'm not going over the, yeah. Okay, that's why I said you got to give me a number and a worksheet. Otherwise, I'm not going over it. I'm not giving you the answers to the quiz. Okay? He's asking about, they've been trying to get this one on the quiz for like 20 minutes. Right. Okay, listen up here, guys. So, for tomorrow, okay, obviously I'm not expecting that the whole worksheet is done for tomorrow, but we're not going to spend a whole bunch more time on naming. So keep those worksheets, use them for practice, use them tonight to study for your quiz. Obviously look at the quiz on Twitter and look at those ones, but okay, you want to practice up so that you are proficient at this naming stuff, because if you can't do the naming, you're going to be lost on reactions, and then you're going to be really lost when we get to the mole equation. So you got to make sure this is a basic skill you have to have in order to progress forward in this unit. All right, so make sure that you are practicing that stuff, okay, and that you are good at it. You're finished? Oh, great.